Thanks, guys. Usually, my talks are usually on tutorials and that kind of stuff, deep into technology, right? And so this is a change in this thing, talking about things which are slightly at a higher level. On the other hand, there are things that we need to understand, right? What we do and why we do what we do, right? We need to have the meta view. And interestingly, it is good that PyData has a few of these talks. I see that I'm looking forward to the keynote today afternoon, talking about system view of machine learning, as well as things like data-informed versus data-driven. So there are a lot of interesting talks that talk about these things. Once you look at, or once one looks at the higher level of what are we doing and the systems view, it is like the blue pill and the red pill, right? Once you take the red pill, then you go in a direction, and there are a lot of things that you realize happen. Anyway, without much further ado, let me go to the next slide. I think already introductions are done, so I'm going to leave it alone. The only thing is, I'm doing my master's in computational finance here, so I have a connection to the Seattle area. Let us first quickly look at the background, right? What does it mean in an analytics big data world? Like the proverbial blind people looking at an elephant, right? Everybody has multiple views to the same domain. So the first one. First of all, big data, of course, is about analytics, right? Most of the time what we are looking at is we are taking a big data, and analytics is the first one. Second, we are building models, right? We are building models one way or the other about the knowns, right? And then the models go and work on things on the unknown unknowns, right? So there is that, you got to understand that what we have a tiny view into a domain, and based on that view, we develop an understanding of the domain, and then we project it. In that sense, I think Don Rumsfeld did a good job explaining the domain, right? The known unknowns and unknown unknowns and all those things. Another interesting point, right, is the known unknown point, right? The things are known, but it is unknown to our model. And this is where evolving models come in, right? You put the model in, and then the models evolve as they, as they start getting more and more information as they work on the project. So that is an important one. And that is where the data scientist as a DevOps, right? As a DevOps person, it is very important that you think of it that way, not as a model that we develop and throw it over the wall and somebody implements it. It's more than that, right? You realize that, yep, I have a model I developed with incomplete information. Now I need to look at and say, how can I evolve this one? And that is part of the data science work. Second one, it is a pipeline. Right? It is a pipeline. You have the very clear-cut data management and data science domains, right? The data management is the collect, store, and transform, right? Those are the various things. Then you have the reason and model, and then you deploy those things. Then the whole visualize, recommend, predict, explore domains. The reason to understand is that when we develop for things like transactional systems and order entry, it's a lot easier, right? You know where things are. It's very clear cut. You can look at it and say, okay, what does it mean? This is where it comes in. I put this one in, and you're done. But here it is not, right? You have a lot more interactivity, a lot more systems view, and a lot of things. As we will see more, we will see that it's a lot more systems view, and we need to think about the whole pipeline, not just a tiny piece of it. 3, I'm sure you have heard of the volume, velocity, variety, right? These are the 3 big data stuff. But there is more to it. There is the context and connectedness, right? Like we talk about the social network. Even graphs are important in many other places. Then there is also the inference, intelligence, and the interface, right? The three eyes. It's important to think in this area and look at it and say, okay, this is intelligence is all my algorithms. Now I have an inference that I make on that one, and then I'm able to bring the interface to the appropriate project, right? Maybe it is a dashboard, maybe things. I have a couple of slides which talks about the various designs and the architectures. This we talked about earlier, the data scientist DevOps, right? The data scientist has to think. That person has to think as a DevOps person. And think of it as right, you have the lab, analytics in the lab, where you go in, you develop the models, you based on things, and then you also have analytics in the factory where you need to, you go in a world of automated systemic world, right? And the couple of interesting things, I'm sure you all agree, you all have come across this one. Even if you put esoteric models, you got to explain it, right? The model should be explainable, they should be transparent, otherwise it's not going to work, right? So those are some of the things that you have to think through and say, I do these things, now when I go in, I also have to think of when it is in production, what are the things I need to do, what are the implications of that one. And finally, I think most of us here will agree on that one. Data is your product. It doesn't, regardless of what you sell, right? Data is the view to a business and the pulse. Couple of interesting things, right? Collect the right data through thoughtful design, right? It's not you get all. You got to have the right data. That means you got to think through and say, what kind of things do I want to collect? What kind of things do I want to store? How do I want to store it? What kind of relationships do you want to capture? And it doesn't end there, right? Give the data back in a powerful way, right? The users have to, I'm sure we all have seen huge dashboards, right? That have all kind of things in there, right? And then don't overwhelm the user, right? The users have to feel safe. They have to feel in control. That is where you look at it and say, maybe things like the drill down, right? So you see a view, they can say, no, I want this one, they pull it in, they drill down. Now users are in control, they are able to interact with the data. There is another interesting aspect to it, is actually not about the technology, but the way you develop a product, right? A complicated product, never launch a complicated data product, especially on a data product, because what happens is it becomes too overwhelming for the users. It becomes too difficult to manage. You need the feedback. You slowly, iteratively, develop the product. You slowly add the features, and now the users are able to adapt to your product. You are also able to adapt the product because now you realize what things are happening, where things are happening, that kind of stuff. Anyway, these are about 3 or 4 points just to keep in mind. And let us go into the data. And I like this picture. This is interesting. I haven't gone there yet. I think one of these days I'll have to go there and see how it is. This is the History Museum in London. Data swamp. Right? We have all seen this one. People talk about data lakes and data hubs and that kind of stuff. In the end, they end up in a data swamp, right? The company comes in, it says we need Hadoop, we need Spark, we need Azure ML, etc. Suddenly, all these things come in, people buy machines or they go into the cloud, they get all these things in, you have data coming in, right? Data coming all over the place. After 3 months, what happens? Everything is, it is a mishmash, right? There are all kinds of things going in. So suddenly people realize, hey, I can't take the data out, right? I can't use it because this has different semantics to it. Data curation is an important one. When you put the data in, when you build a system, don't start creating Parquet files or CSV files without thinking through and say, okay, how does it fit in the bigger system? If a data curation, it need not be very esoteric, as you don't need huge systems, but at least make sure that you publish a schema, make sure the data is there, the files are there, they are organized well, and they can work together. Right? I have a few other things that I talk about. Yesterday there was an interesting talk. Right? Van was talking about the data gravity and the data mass. Right? You need the right gravity and the right mass. You don't want a molasses there, right? You want the right level of data gravity, and that aids your systems very well. This was an interesting, I was looking at LinkedIn and I thought this was an interesting, as I was preparing this one, I saw this blog. You have a layer, right? It need not be exactly like this, but at least it gives you the feel of you have a governance of some sort, you have the cleansing. It need not be all of these pieces, but you realize that, yeah, this looks like an interesting way of organizing data. So that is fine. You have the data lake. All these things are working. Big data to nowhere. This actually happens a lot more probably than we think in many ways, right? People go in, people start putting data in. There is this huge, Hadoop infrastructure, whatever it is. You have all the big data sitting in there. So the business comes in and says, hey, what's going on? I want to see something. They say, yeah, I have the big data. I have the Hadoop. Everything is there. So, and yes, you can see, you can actually see the HDFS. You can see the Spark GUI. And the business looks at it and says, huh? Right? Because what they are looking at is capabilities, right? So what you got to look at and say, I need to build a full stack. I don't want to go and build one. I have a couple of slides we talk about it, the MVP, right? For example, instead of that one, if you start with the logs for it, right? You put the logs in, you are able to make some inference. Business comes in and says, oh yeah, what is going on? You can say, hey, looking at the logs, it looks like, people are buying our product at 1 o'clock between 1 and 2 a.m., right? Because I can see that is where the maximum transactions are. And looking at something, it looks like, I don't know, males 30 to 40 or whatever, right? Now the business is interested. They look at it and say, oh yeah, that looks interesting. So tell me how much of our revenue is coming from that particular segment. Then you can go back and say, oh, no, we haven't yet put the order data isn't, but we can. So now you have an interactive, now there is a way of, so this is how you interactively build that one. Don't go in and put all the things in one place and say, hey, I have the data. That doesn't solve the problem, right? You have to have the inferences. Going back, again, a quick canonical architecture, right? You have the data hub, right? You have some level of landing zone, and then you have a data hub. That is where, like we talked about earlier, you have a curated data that goes in the data hub, right? And there is also an in-memory hub, right? We do have the real-time, so keep in mind that there could be things that you need to do real-time, so you also have a real-time hub of some sort. And then the other side is the analytics hub. That is where all the analytics live. And we have the reporting hub, right? So now what happens? You have the data comes in, it goes in, it is sitting there in a curated area. You have a place for analytics. Of course, I have put all the Python Python libraries. Of course, you're all familiar with the various libraries and the frameworks that you can use. And so the first thing that happens is you have people who look at it and say, hey, I need a dashboard. And I need reports, right? Reports need not be just reports. They could be like we were saying earlier, right? Give the users control to pivot the data. Give the users control to look at the data in different ways. Give the users to select data subsets, right? So all those things happen at the reporting hub. But then that is where talk about the faster response with aggregated data subset, right? For example, somebody will come up and say, hey, I want to compare the uniques between this year and last year. Computing the uniques over multiple dimensions is a big task, right? And if you want exact uniques, that's a lot more, lot more computational, etc. Right? So now you can say, now I can run the analytics and I can give you the results, say, for example, in a couple of hours. Right? So now you have bifurcated the things, you have put the things in place, and you also have a dashboard. Now you develop this stack, right? So that you have these things in place for a data set, and then as you add more data into your data hub, you can do more analytics, you can do more in-memory this thing, and then the ecosystem grows. Instead of just developing the data hub. The next slide, right? This I like this picture, right? The MVP stack, right? You don't go in and say, okay, let me start building the wheels, right? Instead of that one, you give them the simple, right? The simple way of moving around, and then you add more things to it, right? Then you add, you make it a bike, you make it a car, etc., etc. Of course, you can look at it and say, if I want a car, a snowboard is not going to help, right? A skateboard is not going to help, right? Which is true. But this thing is at least you can move around, right? You don't know that you need a car. Maybe you need something else, right? So this, I thought, captures the essence of how the MVP of an analytics stack and at least the pieces, right? You have to look at it and say, what are the pieces I need? How do I combine these things together? So anyway, that is if you take one lesson out of this talk, I think this should be it, saying that I want to build the whole bigger picture. I want to build the stack and have data slices rather than just build a data hub, which is fine, but then it takes a lot more time to develop it, and also you don't know what all things that people need. So which is fine. Now let us look at the next one, a data too far. This is interesting, right? Because this we all have come across, right? You have CSV files, you have the GC files, all these things are running around. Because what happens is, this is big data, right? You might have things, you might have captured some features in some place, and then suddenly what happens again? The same story, right? The data grows. It's very difficult for somebody to combine things together. In fact, one of the things that got to look at is putting the data together from different areas, right? That itself is a big task. It is not the computation, it is the ability to get these things together semantically coherent, and that itself is an important one. That is where things like data pipelines that come in ensure the correctness. The temporal congruence is important, because you have data which says, okay, this is a transactional data, it is, per hour, per minute, whatever it is, and then you have something else which says, okay, this is aggregated data per week or per month. They have to come together, right? If this is 1 to 15 and this is 10 to 20, then there is no way you can compare them together. And once you aggregate it, there is no way you can take it apart. The next one is more interesting, right? This is where is the tofu, right? This is all fine. So we have the right data, we have data, this thing. Now we start putting interesting algorithms on the top of the data. What happens? For example, I'm sure you all heard of the Netflix price, right? Who hasn't heard of the Netflix price? Nobody, right? Good. Yeah, maybe I shouldn't ask it that way. Anyway, so the Netflix price, right? It was fine. They had $1 million bounty on it. People did all kind of stuff. There were huge ensembles, I think 50 ensembles or something like that coming together, 50 algorithms coming together. You got the lift of, what was it, 10%, right? 0.1. They got the lift. Everything is fine. So now you look back and say, oh yeah, so did they implement it? No, they didn't. Right? They did not implement. They may have put part of it. They didn't implement the whole thing. The reason was that even though you got a lift, it was a lot more difficult to implement. That is one. Second, they moved on. So one of the interesting things about Netflix, right? You know that now they are producing shows. You know why they are producing shows? It's because of a very simple reason, right? They have gone past the rating of 1 to 5. They actually know the semantics of movies. If you look at the semantics, you can see that they have movies which say, movies which show whatever, rain in Prague with the hero and the heroine walking away, or whatever it is. It's not walking away, but some romantic this thing, for example. Or they can look at it and say, car chase in the middle of a highway with a lot of fire, right? So they actually know the semantics of what people watch. So once you know the semantics of what people watch, they can easily go back to the writers and say, I don't know what you write, but I need these 6 things. Right? It's very easy to say that, right? It's very, now you can look at it and say, that is why they are developing the shows, right? If you look at the shows, you can see that there are things that they develop. It's not 5, you're not going to go and say, oh, I need a show that gets 5 rating. You'll say, I need a show. They look at it and say, yeah, I need a show where there is this politician person. They will look at it and say, yeah, Kevin Spacey, I think he's the person to do it. Suddenly you've got a thing coming up. And that is the key. And that is the insight, right? The ability to take ability to take a thing, whatever it is, right? Whether it is a TV show or whether it is, I should be careful talking about Amazon because I'm sure there are a lot of Amazon folks here. So, whether it is about things in Amazon, etc., you look at it, you are able to take it apart and you can say, oh yeah, these people bought this one, they will also buy this one because of various reasons, right? It is not because just, the shopping cart affinity, it's more than that. Right? Yeah, and then you can look at it and say people who like this, maybe they like this particular thing as well, which is no more, they are not the same, but they still, and the ability to understand these things, that's important. On the other hand, you also have to look at it and say, just because there is a statistical significance, that does not mean it's a business significance. You know that there is a huge, there is a lot of discussions about the p-values, right? People are looking at and saying p-values, don't use p-values, use the statistical significance. The reason is this, right? You look at and say, oh yeah, I have got, the p-value is less than 0.05, which is fine. It is not bad because it is an indicator. But just looking at that one saying, yep, I had a p-value, this one, we should do it immediately, is not the solution, right? You have to look at it and say, yes, I got this one, but what is it? Oh yeah, I got a lift of 0.02 or 0.03. You look at it and say, is it significant? Is it significant for me to say, okay, change my, A/B testing, change my view of the navigation or things like that, right? And so those things have to consider before we go in and put a model in practice. What Martin was talking about, right? Knowledge is a process of piling up facts, and wisdom lies in their simplification. And that's important. You simplify it to a point and look at it and say, yes, this makes sense. This makes sense from a statistical significance point of view. This also makes sense from a business significance. On the other hand, you also have to have the other side, right? Just because, for example, things that when I'm working on forecasting, right? You do the forecasting. But you also have to have statistical significance in your forecasting so that when people look at it and say, how did you forecast? What kind of things happened? You have to look at it and say, yep, there is enough statistical significance for me to say that, yep, this with reasonable this makes sense. So let us go to this is an interesting one, right? I'm sure you all have followed the UK general election as well as the Greece, this thing, right? In both cases, these are interesting times for analytics, right? In both cases, the polls got it way wrong, right? The polls got it way wrong. The reason they got it, when I saw this in Twitter, I thought that this is the right one, right? The biggest danger of analytics is this, getting reasonable looking answers from a reasonable looking data set that is flawed, right? You look at it and say, yeah, this makes sense. It doesn't make sense. The reason is this, right? There are things like publication bias, right? You only publish, the publication comes out of only the things. It's a filtered this thing, right? It is not everything doesn't get you don't get it published whatever it is. There is this concept of an homogeneous ensemble, right? Homogeneous ensemble is an oxymoron. Right? If you have an ensemble, and if they all do the same thing, it doesn't make any sense. Why do you need an ensemble? You just need one of them. Right? You need ensembles that don't agree. They disagree. They look at it and say, no, I am looking at this part of this thing, and I don't think this is right. Right? And then the same as the file drawer effect, right? There are a lot of things that go under the file drawer. They get filed, and they never see this thing. You don't see that one. So these things are important, and Yogi Berra said, you can see a lot just by looking. It's true, right? The UK elections and the Greece ones, right? They were an eye opener in that sense. You should have seen right? I'm sure you have seen before the polls were closed. They will say, oh yeah, this is huge, this thing, right? But in the end, it got totally, they were way wrong. And this was on a span of a few days, right? It is not like a span of months or something like that. It's not like seasonality or some unforeseen things happen. No, none of these. So the key is this, right? Don't torture the data, right? If you torture the data, it will tell you what you want to hear. But that's not what you want to do. So the whole, I'm not going to go into details, but this whole, area of, right? The overfitting, the bias with, variance, trade-offs, all kind of things come in the picture, as well as looking at the right data, looking at multiple algorithms, all of these things. Then this will become more important. This will become a lot more important as we get into more and more interesting analytics, right? And as we start, it's not as we start, probably even now, as we start depending on machine learning and analytic systems and big data, right? All these things come together. When we start depending on them, then we have to have developed the systems in such a way that we are able to at least differentiate between them, right? There is this whole line of thought which talks about outliers, right? They really are not outliers, right? You got to look at them and say, we need to look at and say, they are not outliers. You have to look at them and say, they are saying something that we don't understand or we don't see, or that's something that we need to look at. This is an interesting UK government of UK design principle. Excellent, nice this thing, right? So you look at the first one, right? It says start with needs. Could you tell me whose needs they are talking about? There is an asterisk in there, right? Any thoughts? Customer. Not the government's needs. So that's why they put an asterisk in it and they say, look at the need of the customer. Don't look at the needs of the government, right? So, excellent, thank you. Design with data. Understand the construct, right? Build digital services. Be consistent, not uniform. Very interesting, excellent insights when we start building data products. I just wanted to, put it in such a that I thought this is a very, So, taking that team to the next level, right? Data alone is not enough. This is another. I don't know how much this thing, right? You can look at it and say, give me some data, I'll be able to make sense of it. Maybe, maybe not. Because it is also, it is induction, it's not deduction, right? You can, so mathematical, you can deduct. But this is not, this is a lot more than math, right? This is the data. You do need to understand some parts of the domain. For example, the ROC curve, right? If you look at the ROC curve, maybe you look at it and say, where should I, should I go, less of this one, or for example, if you are looking at, say, the legal this thing, right? What do they call it? Exploration, or right? In that point, where you want to capture all the things, right? You want to capture everything that you can. Even if there are, the false positive versus false negatives, all those things, right? You want to capture, you want to make sure that you capture everything. So the question is this, right? How much of that you capture are right? And on the other side, how much of right did you capture? Right? How much of right did you capture is what is important in some other places. On the other hand, for example, in search, the question is how much of that you capture are right? Right? If you have first 5 elements that are wrong, even if the rest of them are right, the search is done, right? Anyway, there's an interesting, I saw one. Where was that? There was, I don't know where it is. They said that you can actually hide a dead body in the page 2 of a search thing, right? So it's interesting, right? Nobody looks at page 2. So those things are important to say. And that depends on the domain. And the other thing, of course, is this is more for the managers, right? Machine learning is not magic, right? You cannot expect gold from a pack of data lead of some sort. I don't know. It might be exaggerating, but still. The data has to have enough knobs and dials. You should have enough things to move around, right? You should be able to. If the data is not expressive enough, you will not be able to get things out. There are a lot of this thing going on which says, okay, we have the data, so let us make some inferences, right? Got to look at it and say, guys, you can't. You got to have enough things in there to make inferences. Taking that one to the next one. Right? This of course is Google's this thing, right? More data beats clever algorithm. That also is interesting, right? Spend time on algorithms that grow with the data. Many models, of course, the like we talked about earlier, ensembles learn from multiple models. do the ensembles. Make sure that you have enough breadth in your algorithms, breadth in your data, so that you are able to manage them well. Of course, the last one, I think this is my last slide. Correlation does not imply causation, right? That we know, we all know that one, but still it needs to be said, every time when we talk about these things. So in short, build a full stack iteratively, right? Don't go in and build the whole stack. Build it iteratively, learn from the domain. Identify the right business problems, create valuable data perspectives. That I think is an essence, right? You create interesting and valuable data perspectives, frame the problems, and finally, embed inference and intelligence into products, right? To embed I think I had written a blog earlier in LinkedIn, one of these. This is like the electronics, right? Earlier, people had electronics, and there were engineers who would go out and say, I want to embed, I'm helping my customers to embed electronics in their products. Right? Now electronics is there everywhere, right? So similarly, intelligence and inference, right? Embedding them in various, in the products. And that's what in anything that you do, any area that you work on, and that is where the key is. That's where the machine learning, data science, all these things will become interesting. Thank you very much. And I left it, we have how much time? Yeah, good, excellent. I do want to, I was taking a chance, but I said I'm going to leave 10 minutes out for folks to talk about, suggestions, anything that you have seen in your, this thing, right? Rather than me talking the whole time. I'm leaving up to the folks to say, okay, folks, what do you think? Did it make sense? Is it the right, the good, the bad, and the ugly? Any brave souls to, yes, sir. Which one?
I thought your talk was good. Had that review.
Thank you. What about your experience in any, people who have seen that, right? There might, I'm sure you have seen, there are experiences where you look at it and say, hey, this has happened to me. We have built in, right? We have built the things without, and the business is coming, asking questions, that kind of stuff. Which is fine. Yeah, go ahead.
Centralized data on the model of putting little data sensors on cows.
Yep.
Do you see a future in sort of decentralizing data that way?
Oh yeah, absolutely. Thank you. That was my point about embedded intelligence in the products. The time has come, right? That keynote was excellent. Time has come. Right? What he was talking about was, thank you for it. It was beautiful, right? Usually we look at it and say, we collect all the data in, and then we put it in this big place, right? And then we have this Spark or whatever, Azure ML or whatever it is, he starts running on these things, right? Instead of that one, we have to look at it and say, I want to embed this intelligence in the wherever the data is. Right, he was talking about the the aircraft, right? 5 terabytes of data per flight from Boston to San Francisco or whatever it is, right? Or San Francisco to Boston, whichever it is, right? So, taking that data and putting it, using it immediately, right? It is, and that is going to happen. What will happen is all these tiny things, right? They are not tiny anymore, right? They will have intelligence built in. They will be able to take the data in. They will be able to make things that we need to make. But there is one point in there. One of the things that happens is, you have to look at it. There is a systems principle which says, put the feature at the lowest layer possible. In the sense that, if you put it any layer lower, you lose the context, right? For example, if you want to look at and say, if all the cows are there and they want to go into one direction, that cannot be made by one cow, right? You got to look at it and say, where are all others going, and then you have to go in. Just for, it says, so on the other hand, if you put the intelligence at a higher level, what happens is you lose the control, right? Because now you have to look at it, you have to wait for the data, you have to do this one, then send back, it says, oh, do this one. So that balance has to be there between the control and the context. Of course, remember this parameter servers for the deep learning. What it does is, because deep learning it has to be distributed, right? The capability has to be distributed. You have multiple clusters or multiple boxes running all these things, and there is a parameter server, and they update the parameter server. So they get best of the both worlds. They can look at their part of this thing and do this thing, as well as they can exchange the context, right? They can elevate the context to a next level. Thank you. Excellent. Good question. Thank you. And there are 2 more talks coming up. I'm looking forward to that one. Like I was saying earlier, today afternoon, right? Systems view of machine learning. That should be beautiful. And the second is data informed versus data driven. Those are a couple of interesting talks that looks at it from this domain. Yep. Yeah, probably. Thank you. Yeah, excellent. Yeah, together with qualitative. Yeah. I should have put non-quantitative information. Thank you. Thanks, guys. Appreciate it.